Welcome back to Pocket Rod. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Okay, we're going to be talking about angles today, and also reference angles. The first thing I want to remind you is that if we have quadrants and we start at 0 degrees here, then this is quadrant 1. This is like your x and y axis. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So that's just a reminder from algebra. Okay, when we are plotting angles on a graph, then the one thing you need to know is that when your angle is positive, you will rotate from 0 degrees in a counterclockwise direction. Okay, if your angle is a negative angle, another place we'll see negatives. If an angle is negative, it doesn't mean it's below 0. It has to do with the direction you're rotating on a graph to be able to draw it. So if your angle is negative, from 0 degrees, you will then go in a clockwise direction. Positive, counterclockwise, negative is clockwise. Okay, let's look at 7b2. They're asking what quadrant is this in if you draw the terminal side. In other words, where does this stop? The terminal side, where does this stop? And they want to know the reference angle. We'll talk about the reference angle in just a minute. I always recommend drawing it, okay? So first off, this is a positive. When there's no sign in front of it, it's always assumed to be positive. So since it's a positive angle, we rotate in the counterclockwise direction. So if you're going to draw this on a graph, here's your quadrant. 0 degrees starts there, 90, 180, 270. So starting at 0 degrees, rotating in a counterclockwise direction to 190. Okay, starting here, that's 180. Now we need to go 10 more degrees for 190. So to draw that, we start from the origin, and that would be about 190 degrees. Okay, this is called our terminal side. We started at 0, and I like drawing arrows because this arrow shows which direction that you rotated. You rotated in the counterclockwise direction, and so that is 190 degrees. So what quadrant did we end up in? 3. 1, 2, 3. So we ended up in quadrant 3. And again, just in general, they use Roman numerals for quadrants. If you're using a regular number, no big deal. So then we have to say the reference angle. Okay, by definition, a reference angle is drawn perpendicular, or you draw a perpendicular line from the terminal side to the x-axis. So if there's one thing I can drill in your head, a reference angle is always drawn to the x-axis. And the reference angle is always an acute angle, meaning it's less than 90 degrees, and it's always positive. So here, if our terminal side is here, this is where our angle stops, your reference angle is always drawn to the x-axis. So from this point, wherever this point stops, go up, actually I want to use a different color, go up to the x-axis. So I'm going to go from here, and it's going to be perpendicular to the x-axis. In other words, that line should be perpendicular to the x-axis right there. Okay, so now I've created this triangle, and then they want to know what is the reference angle. This small angle right here that you created to get to the x-axis, that is your reference angle. I know it's hard to see that purple, but this little angle right here that you drew to get back to the x-axis, how many degrees did you go to get back to the x-axis? So to take this line and to go back to the x-axis, we would have to go 10 degrees because 190 minus 180 is 10 degrees. So this reference angle for this particular problem is 10 degrees. Those are the only two things that you need to be answering for that problem. Okay, let's look at 7C3. Same thing. They want to know what quadrant are you in and what is the reference angle. Here you have negative 405 degrees. What does this negative in front mean? This negative tells you the direction you will rotate. When your angle is negative, you are rotating in the clockwise direction. So here, draw your quadrants. 0 degrees is always the same place. So if I want to start here and then I rotate clockwise. This tells you I'm going to go clockwise, starting at 0 degrees. So starting at 0 degrees, I'm going in the clockwise direction. So if I go here all the way around, I've got to 360, but I've got to go 405 degrees. How many more do I need to go to get to 405? It would be 45 degrees. So that's where my terminal side is going to stop, because I started here and I went in the clockwise direction, and I went 360, and then I had to go 45 more to get to 405. So that's where I stopped. So I ended up in quadrant 4. 1, 2, 3, 4. So I ended up in quadrant 4. Now I need to determine my reference angle. The definition of reference angle is what does it take to get back to the x-axis. So I want to go back to the x-axis. So starting here where I ended, I want to go up to the x-axis. So looking at this, what is that angle right there to get me back rotating up to the x-axis? That would be 45 degrees, okay? Because we went around 360 to 405. 405 minus 360 is 45. So that right there would be 45 degrees. Remember, your reference angle is always positive, and it's always an acute angle, so it will be less than 90 degrees. So it's always positive. So there you go, quadrant 4, 45 degrees for your reference angle. Now looking at 7b5, we're going to take this information and now add in trig functions. So for 7b5, they want to know what quadrant are you in, what's your reference angle, and what is the value of the ratio in fraction form. Okay, so here we're looking at cosine of 150 degrees. So for now, I'm not even going to look at the word cosine, I'm just going to draw 150 degrees. What quadrant are we in for 150 degrees? It's a positive angle, so since it's a positive angle, we will be rotating in the counterclockwise direction. So there you go, there's 0 degrees, 150 degrees. Start here at 0 and rotate in the counterclockwise direction, which means that way. So 150 degrees is about right there. And I went in that direction, so that is 150 degrees. So what quadrant am I in? I'm in 2. So quadrant 2, that's one of your answers. We should have 3 answers because it's asking for 3 things. Okay, now it's asking for my reference angle. Definition of reference angle is going back to the x-axis or going to the x-axis. So if I took this and rotated to the x-axis, this is the x-axis, and the line, this line has to be perpendicular to the x-axis. So wherever your terminal side is, you go to the shortest distance. What is the shortest distance to get to an x-axis of wherever you're at? Your line should always go to the x-axis. So this angle right there, can't see that, this angle right here is my reference angle. Well, if this is 150 degrees, this line represents 180. How much is that angle? Well, 180 minus 150, that would be 30. These two angles right here should be supplementary. 150 plus 30 is a straight line, 180. So my reference angle is 30 degrees. A reference angle is always acute, less than 90, and it's always a positive number. Okay? Now the last thing that they're asking for is the value of the ratio, cosine. We want cosine of 150 degrees. What is the definition of cosine? Cosine is adjacent over hypotenuse. Here's where we look at our sines. If we were to be right here, r going 150 degrees, let's just pretend we had a point right there. And we were looking at need to get new dry erase markers. We were looking at x and y values for that point. This point right here has an x value and a y value for a coordinate. Okay, how do I get to this point with an x and y value. If I start at the origin and I went in the x direction, I went in the negative x direction. Okay, starting at the origin, and I go this way to the left, then that is a negative x value. I don't know what the value is. It doesn't matter what the value is. Then when I stop here and go up in the y direction, I went in the positive direction. Then your hypotenuse right here, we're going to look at all sides of this right triangle. That's a right triangle right there. So the x portion of this bottom of the triangle would be negative. The y portion would be a positive value. Hypotenuse will always be a positive value. Because if you go through Pythagorean theorem and said whatever this value was, a negative value, because you're going to say this value squared plus this value squared equals the square of this. Well, when you square a negative, it's going to end up being a positive. So your hypotenuse will always be a positive value. Hypotenuse is always positive. So if I look at cosine is adjacent over hypotenuse, so cosine of this angle is adjacent. What is the side that is adjacent to me? It is a negative number. So if I look at the side that's adjacent to me, that would be a negative value, and then the hypotenuse would be a positive value. A negative divided by a positive is a negative. So cosine of 150 degrees, when we're in quadrant 2 with cosine, you're going to end up with a negative number. If you don't believe me, you can put in cosine of 150 degrees in your calculator. If you do 150 and then do cosine, you will end up with a negative decimal. So a negative divided by a positive is a negative. So I know that our value is going to be negative. Okay? Now, what is the value of cosine of, then you look at your reference angle. If we look at this triangle right here, 90 degrees right there, 30, that means this has to be 60. This is a special right triangle, a 30, 60, 90 triangle. That is a special triangle. It falls under one of the special triangles, 30, 60, 90, 45, 45, 90. If you refer to page 18 in your instruction manual, it's going to have values for the special angles in your special right triangles. It'll have values for cosine, sine, and tangent of 30 degrees, cosine, sine, tangent of 60 degrees, and cosine, sine, and tangent of 45 degrees. Okay? The book tells you to memorize them. If you're in my class, I allow you to write them on your formula sheet. Okay? So the fact that we're looking at cosine here, this is where we get our cosine, and we did 150 degrees, but if you look at the reference angle is 30. So if we go back and you look at your formula sheet of cosine of 30 degrees, then cosine of 30 degrees is square root of 3 over 2. Because we can't, unless we have numbers on these triangles, we don't know what it is, but because it's a special right triangle, then we do know the value. But it's really important to have this negative sign here. Okay? So that is the answer for that one. Okay, let's do another one of these. Go down to 7B6. Tangent of 225 degrees. Same thing. We want to know what quadrant are you in, what is your reference angle, and what is the value of the ratio in fraction form. Okay, not in decimal form. You could put this in your calculator and get a decimal. They don't want that. They want it in fraction form. So, okay, so the very first thing is we're going to graph or draw a picture of 225 degrees so we know what quadrant we're in. Okay, so because determining what quadrant you're in is going to help you know the sign if tangent of 225 degrees is a positive sign or a negative sign. Okay, so here we have our quadrant. Here's 0 degrees. It's a positive angle, so that means we are rotating in the counterclockwise direction. Okay, so starting here at 0, we're rotating in this direction. Okay, we got to 180, so now we need to go 225. So all the way to this line would be 270, so it's not that far. So it's somewhere right in here. 225, that's supposed to be an arrowhead. So that is 225 degrees. So that is 225 degrees. So what quadrant am I in right here where this stops? I'm in quadrant 3. Now the next thing they want to know is what is the reference angle? The reference angle is always drawn back to the x-axis. You're always going back to the x-axis for the reference angle. So this line right here, if I go back to the x-axis, because that will make that a right angle right there. So what is this? What is the amount of this angle just right there? That's the reference angle, because the reference angle has to be acute, less than 90 degrees. Well, I know that this line is 180, so to go all the way to here, to 225, so you do 225 minus 180, and that should be 45 degrees. So that reference angle is 45 degrees. So my reference angle is 45 degrees. Now it wants the value of the ratio in fraction form. So we're doing tangent, and you're going to use this reference angle right here of 45 degrees because this is a special triangle. 90. This will be a 45, 45, 90 triangle. Again, you can refer back to page 18 in the instruction manual for these fractional values, or if you're in my class, you'll have it on your formula sheet. So we're doing tangent. Tangent is opposite over adjacent. Okay, so I'm trying to add more in my picture. So this angle right here is 45 degrees. So opposite over adjacent. Okay, so if I'm saying there's opposite, there's adjacent. So if I was to draw a point right here, which that's my terminal side, that point, what would my x and y value be to get to that point? Okay, if I start at the origin and I go to the left, is x negative or positive going to the left? That would be negative. So I went in the negative x direction and then go down to get to my y value. Going down would be also negative. Hypotenuse is always positive. So we're dealing with tangent, which is opposite over adjacent. So if I'm standing here, I have a negative over a negative. Opposite over adjacent. So that value would be negative, and that value would be negative. I don't know the numbers, and it doesn't matter, because all I'm using this for is to determine the sign of what sign is tangent in quadrant 3. So a negative divided by a negative is a positive. Okay, that equals a positive number. So then I know that my value for tangent is going to be a positive number. You don't have to write the positive sign. I'm just writing it here to emphasize it will be a positive, because a negative divided by a negative is a positive number. Then I'll use 45 degrees as my reference angle, and I can refer to page 18, or you can look at your formula sheet of tangent of 45 degrees. Tangent of 45 degrees is 1. So the value of tangent of 225 degrees is a positive 1. If you don't believe me, you can put it in your calculator, and you can double check yourself by putting it in your calculator. But using this little graph and chart is how you determine the sign of this trig function. The sign will change depending on what quadrant you are in. Okay, now we're looking at 74, and so we want the quadrant and the reference angle, and then the fraction value of the trig ratio. So notice here you have a negative angle. What does negative in front of an angle mean? It tells you the direction you're going to rotate. So a negative angle will rotate in the clockwise direction. So let's draw a sketch first. So there's my quadrants, there's 0 degrees. Negative 30 means I'm going to rotate in the clockwise direction. So that would be something like that. I'm rotating in the clockwise direction. So what quadrant did I end up in if I just go negative 30 degrees? That would be quadrant 4. So I'm in quadrant 4. To get back to the x-axis, that would be that line right there. And there is my right angle. So how many degrees did I go to get back to the x-axis? It's basically that same angle right there, 30 degrees. Don't say negative 30, because the reference angle is always positive. It's always a positive angle. So to get back to the x-axis is 30 degrees. So Now I want to know the value of cosine of 30 degrees. I have to look at, or cosine of negative 30 degrees. So if I was at this point right there, it's going to have some x and some y coordinate, okay? Well, starting at the origin, to get to my x coordinate would be a positive value, because I have to go to the right, which is positive. Then to go down to get to my y value, or to get to that point, I went down. So that would be a negative. My y coordinate would be a negative value. Hypotenuse is always positive. Okay, I'm dealing with cosine. Cosine is adjacent over hypotenuse. Well, if I'm standing at the angle, the reference angle, which is where that little arrow is, then the side adjacent to me is positive, a positive value, over the hypotenuse, which is positive. A positive divided by a positive is a positive value. So therefore I know that the value will be a positive value. And we're looking at, look at that reference angle right there, that's going to be 30 degrees. So instead of drawing my arrow there, I can draw my little 30 degrees. So if I want to do cosine of 30 degrees, look at either the page 18 in the instruction book, or at your formula sheet at cosine of 30 degrees, and cosine of 30 degrees is square root of 3 over 2. Because they want it in a fractional value, and it's going to be a positive. I don't have to have the positive sign there, I can have square root of 3 over 2. So cosine of 30 is square root of 3 over 2. If you don't believe me, you can put in cosine of negative 30 degrees in your calculator, get a decimal, then you can take square root of 3 and divide it by 2 and get a decimal for that. They should be the same value. Okay, let's look at 7C number 8. They have this little table there for you to fill in. The first thing that they want you to do is sketch. They want you to draw a sketch, and your theta is 300 degrees, okay? They're just telling you here that the hypotenuse length is 2 units. I don't know if that's centimeters, meters, inches, feet. So you can almost ignore this value for right now, but they're just telling you that the length of the hypotenuse is 2. So we won't really do anything with that, but the main thing we want to look at is the angle is 300 degrees. It's a positive angle, so that means we're going to rotate in the counterclockwise direction. So there's 0 degrees. So if I was to draw 300 degrees, so start here, that's 180, go to 270, and it's going to be something like that. Okay, going in the counterclockwise. So what quadrant are we in? We can fill that blank in right here. We are in quadrant 4. Then they also want to know, what is the reference angle? Reference angle is, what does it take to get back to the x-axis? So drawing that line back up to the x-axis means that angle right there means that angle right there. So if this is 300 degrees, then what's left over to get back to there, that would be 60 degrees. So your reference angle would be 60 degrees. That's how much it would take to get back to the x-axis. So now we want to look at the value for sine, cosine, and tangent of theta. And our theta right here, we're going to use the reference angle. We will use the reference angle of 60 degrees to help us determine that. So it's like you have a point right here. You have this x and y coordinate, okay? Would your x value be a positive or negative? Would your y value coordinate, your y coordinate be a positive or negative? Well, to get to this point, your x value, you go to the right, which is a positive. Your x coordinate would be a positive value. Your y coordinate would be a negative value because you have to go down. Hypotenuse is always positive. So if you look at each value, sine is adjacent, sine is opposite over hypotenuse. So if you're standing here at 60 degrees, the side opposite of you is negative. Okay, a negative value. I'll give you a hint. Sine always goes with your y value, cosine always goes with your x value. So sine of 60 is opposite, which that would be a negative value. And your hypotenuse is always going to be a positive. A negative divided by a positive is a negative. So that tells me my sine value will be a negative number. So then we can use our special triangle. This would be a 60 and 90, a 30, 60, 90 triangle. So you can look up what is the value of sine of 60 degrees. So sine of 60 degrees is square root of 3 over 2. If you're not sure and you need to prove it to yourself, go put in sine of 300 degrees. You'll get some sort of negative value. Then you can do what is square root of 3 divided by 2, and those decimals should be the same thing. Okay? So now let's do cosine. So cosine is adjacent over hypotenuse. So if you're standing here at the reference angle, cosine is adjacent over hypotenuse. The adjacent side is going to be a positive value. I don't know what the number is, I just know it's a positive. And then over hypotenuse, hypotenuse is always positive. Positive divided by a positive is a positive. So we know that our cosine value is positive. Now we're looking at 60 degrees, cosine of 60 degrees. So looking at your formula sheet or in the book, cosine of 60 degrees is 1/2. And you don't have to have the positive sign. Okay, now let's do tangent. Tangent is opposite over adjacent. So if you're standing here at your reference angle, the side opposite of you is a negative value. So that would be a negative. The side adjacent to you would be a positive value. Negative divided by a positive is a negative. So therefore we know that the value of the tangent would be a negative value. So, and we're looking at the reference angle of tangent of 60 degrees. And tangent of 60 degrees is square root of 3. And by the way, they wanted these values in fraction form, not in the decimal. So the instructions say to put them in a fraction form. Okay, we're looking at 7C, number 7. And this problem gives you a point to graph the point. And then they want the 6 trig ratios with this given point. And I will tell you that the book leaves these answers in radical form with fractions. So how do you go about doing this? Remember, this is just an XY coordinate. Alright, so X, Y. That's an XY coordinate. You can plot that on a graph. So plotting that XY coordinate, I'm just going to put 3 tick marks on each. Okay, go in the positive 1 in the X direction, negative square root of 3. I'm going to leave this in a radical form. The only thing I'm going to change it for is to plot it, to graph it, because I don't know what square root of 3 is to graph it, but I think it's somewhere around 1.7. So I'm going to do square root of 3. Just for graphing purposes, that is the same as negative 1.7. Okay, I'm only changing it into a decimal for graphing purposes. So going over in the positive 1 X direction, then down 1.7 gives me a point about right there. So I can draw a line from the origin to that point. Okay, that is my hypotenuse. I can then draw the rest of the triangle because I went from the origin positive 1 in the X direction and then down 1.7. It's a small little triangle. That's my right triangle. Okay, I'm going to blow it up to a bigger scale. What I did is, starting from the origin, okay, let's pretend like this is the origin. I'm going to blow it up. I went over positive 1 down 1.7. Okay, so that was positive 1, that was negative 1.7, and then that is my hypotenuse. Okay, let's pretend that's a straight line. Okay, so how do I find my hypotenuse? This is a right angle. I went over X, down Y, right angle. How do I find my hypotenuse? And do I even need the hypotenuse? I do need the hypotenuse because I can tell you. We're going to do the 6 trig ratios. Sine is opposite over hypotenuse. Right there I need hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay, so you can see we need the hypotenuse to be able to find the trig ratios for sine and cosine. Okay, so down here on the picture that I drew, I forgot we need to be using the radical. So this needs to be square root of 3, negative square root of 3. Okay, so I need to find the hypotenuse in order to do all of my trig values. How are we going to find the hypotenuse? Pythagorean theorem. Okay, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. Well, one of my legs is 1, so 1 squared plus square root of 3 squared equals hypotenuse squared. 1 squared is 1. Square root of 3 squared. Okay, just let me write it out so you can see. Square root of 3 times square root of 3. What is square root of 3 times square root of 3? That is square root of 9. Square root of 9 is just 3. So when you do a radical times itself, it's like the radical cancels. Okay, so basically what we had was 1 plus square root of 9. Square root of 3 times square root of 3 is square root of 9, and square root of 9 is just 3. So 1 plus 3, 4, but we're solving for h, so you have to take the square root of both sides. So turns out that the hypotenuse is 2. Square root of 4 is just 2. So the hypotenuse is just 2. We went through all that work to find the hypotenuse, but we're not done with the problem. So now we can find all the 6 trig ratios, okay? So sine is opposite over hypotenuse. We need to know where theta is. Where is theta? Theta is always going to be right there at the origin, okay? Right there at the origin. That's where your little man will be standing to find all your trig values, okay? So when we're talking about sine is opposite over hypotenuse, we're going to be standing right there closest to the origin. So sine theta is opposite, which would be negative square root of 3 over hypotenuse, which is 2. Okay, that is one of our trig values. Cosine theta, and we don't know what theta is, and that's okay. We're not told what theta is. Cosine is adjacent over hypotenuse. Adjacent is positive 1 over hypotenuse, which is 2. Okay, then tangent theta. Tangent is opposite over adjacent. Opposite of me is negative square root of 3. Adjacent is positive 1. Always reduce if you can, so we're just going to call that negative square root of 3. Okay, that's your tangent value. So that's tangent. What I want to show is that your trig functions can be negative or positive depending on which quadrant you're in. Here we're in quadrant 4. Sine is negative, cosine's positive, tangent's negative. Okay, the other 3 trig functions are the reciprocals. Okay, reciprocal of sine is cosecant. So cosecant is reciprocal of that, negative 2 over square root of 3. Can you leave it in that form? No. You have to get rid of the radical in the denominator. How do you do that? By multiplying it to itself. Then that would be negative 2 square root of 3 over square root of 3 times square root of 3 is square root of 9. Square root of 9 is just 3. So that would be cosecant theta. Then do the reciprocal of cosine, which is secant theta. Reciprocal of that would be 2 over 1, which is just 2. Now do the reciprocal of tangent, which is cotangent. That would be the reciprocal of negative square root of 3, which would be 1 over, still negative. Can't leave radical in the denominator, so you have to get rid of the radical in the denominator by multiplying it by itself. And that would be negative square root of 3 over 3. And those are your 6 trig ratios.